So let's say you have a vector A, and this vector A has coordinates, well, those are not coordinates, has components 1, -3, and 2. And vector B has components of -1, 1, and 1. Now, if I were to ask you, what is, and this, by the way, is number 45, chapter 7.2 of our math book, Advanced Engineering Mathematics. What if I were to ask you the magnitude of A and plus B? Well, I would go from the inside out. So I would first find what A plus B is. And that would be 1, -3, and 2, plus -1, 1, and another 1. Now, if I add each component, 1 plus -1 is 0, -3 plus 1 is -2, and 2 plus 1 is 3. So this would be my vector, right? This would be my A vector plus my B vector. So now the magnitude of my A vector plus my B vector would just be the magnitude of this. Well, how do we find a magnitude? We apply the Pythagorean theorem. We can apply it in 3 dimensions as well. It's going to be the sum of the square of the components, all elevated to the power of 1/2 or square root. And that would be 4 plus 9, which is the square root of 13. Now let's think about it visually for a second, if that makes sense. Let's say we have, actually I didn't want to do that. Let's say we have a 3D axis system. With the right-hand rule, you'd notice that this is my k-hat. And let's say we have this vector over here. So I'll use the tool to be kind of neater. Let's say we have that vector, and the projection of this vector onto the, I would say, I hat, j hat plane is this one over here. Then we can see that there's a j hat component. So say this is, let's call this C. Say this is A. This is component A, component B, component C, and component D. Well, we know that to get to C, this is a right triangle, so C is going to be equal to the square root of A squared plus B squared by the Pythagorean theorem. And we know that the magnitude of, oh, I used C twice. So let's say the vector is actually, called D vector. And the magnitude of the D vector right here, well, what is that magnitude going to be? Well, that's going to be C squared plus D squared square root. Well, if I put this in here, then I would get that the magnitude of D is going to be equal to the square root of A squared plus B squared squared plus D squared. And it comes down to, the radical goes away and we have A squared plus B squared plus C squared, which is the reason why we used this formula to find the magnitude of a 3D vector. All right. This was the problem.